Good morning, everyone, and welcome to another fascinating edition of your quarantine notes. Today we finish up our conic section unit with our discussion of hyperbolas. These are probably by far the most complicated conic sections to graph. Their equations are very similar to those of ellipses, but they are a little bit more difficult because you'll see of a minus sign in between, and we also, in order to graph them, we need asymptotes, and so that's going to be another thing that we need to solve for. But a hyperbola is formed by cutting through a double cone so that you have sort of symmetric, almost opposing parabolas when you cut through the sections of both the cones. And so as you can see, we kind of create these asymptotes, and our hyperbolas could open either horizontally or vertically. If they open horizontally, then your x squareds will be positive, and if you open vertically, your y squareds will be positive. All of these measurements are the same as they were in ellipses. So your A is your distance from your center to your vertex. Your B is the distance from your center to your co-vertex, and your C is the distance from the center to the focus. To find your C using your A and B values in a hyperbola, you're going to add your A squareds and your B squareds. So an easy way to keep this in mind is your A squared is always written first in the standard form of your equation. A couple of new vocabulary terms. The segment that connects your vertices is known as the transverse axis in a hyperbola, and the segment that connects your co-vertices is called your conjugate axis. And this is the equation of your asymptotes if it's a vertically opening hyperbola or if it's a horizontally opening hyperbola. And just as a reminder, now that we know all of our conic sections, in order to distinguish between them when they're in general form, we're going to follow these basic rules. So in general form, if the coefficient on your x squared and your y squared are exactly the same, then it's a circle. In general form, if the coefficient on your x squared is anything and you don't have a y squared, that's a parabola, or vice versa, if you don't have an x squared and the coefficient on your y squared is anything. Or in other words, if you were to multiply the coefficients and you got 0, then you would have a parabola. An ellipse is where the coefficients on your x squared and your y squareds are different but both positive. Or I should say, maybe not even positive, but they have like signs. Their signs match. And to have a hyperbola, the coefficients on your x squared and your y squared are going to be unlike. Or in other words, when you multiply those coefficients, you would get a negative number. So you'll want to be able to distinguish between all four of them. All right, so if you take a look at the first problem here, we're asked to write the standard form of the equation of the hyperbola with foci at -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2. So this gives us a lot of information. One, it tells us the direction that we're opening, because as you can see, the x's are the value that is changing, not the y's. So this tells us that this is a horizontally opening parabola, so we're going to start with our x squareds. It also tells us our center, because our center is exactly the midpoint between your foci or your vertices. You could use either set of points, find the midpoint of it, and get your center. It also, the foci gives us our C value, and the vertices give us our A value. So the distance between your foci is 6. From -1 to 5 is a distance of 6. So the focal length, or the distance from the center to the focus, to either focus, has to be 3. And the same thing with your vertices here. The distance between your vertices is 4. So from the center to your vertex is going to be 2. So that gives us our a squared, which is 4, and our c squared, which is 9. And we can use our formula of c squared equals our a squared plus our b squared to find our b squared, which must be 5, because 4 plus 5 is what gives us 9. And now we have enough information to fill into our equation. So we do x minus our x coordinate of our center point squared minus y minus the center point y coordinate squared equals 1, and the x squareds are over the a squared value, and the y squareds are over the b squared value in this case. So a squared always comes first in your hyperbola equation. Okay, in example 2, we're actually graphing this, and it's not in standard form. So the first thing we're going to do is get it into standard form by dividing by 16 on both sides. That gives me x squared over 4 minus y squared over 16 equals 1. So I can see that my center is at 0. My a squared has to be 4 because it comes first. My b squared is 16. And this is going to be a horizontally opening hyperbola because the x squareds are the positive ones. They come first. So to graph a hyperbola, like I said, it's tricky. First you graph your center point, and then you graph your a and your b values. So you count, in this case, to the left and right 2, because the a value is under my x's, and I count up and down 4, just like as if I were graphing an ellipse. What this gives me is what's known as my central rectangle. So once I have those 4 points, I quickly sketch a rectangle around them, and the reason why that's important is because the corners of that central rectangle, those form my asymptotes. So I can draw in my asymptotes, and because this is a horizontal opening hyperbola, I'm going to draw my hyperbola on the left and the right. So these are my vertices, and then these numbers, or these points up and down here, are my co-vertices. So they're not actually part of my hyperbola. Okay. All right. In this next example, we are sketching the hyperbola by and then finding the equations of the asymptotes. So we kind of do the same thing that we did before. In this case, because we're in general form, we need to get this into standard form for graphing. I group my x's, I group my y's, and I put my coefficient on the other side. In this case, I have to complete the square. In order to do that, I need to factor out my leading coefficient first. And since I had to complete the square by adding 1 times 4 over here, I have to add 1 times 4 on the right side as well to keep my equation balanced. So then when I do this, I end up with negative x plus 1 squared over 3 plus y squared over 4. So in standard form of a hyperbola, we always want our positive variable to come first. So I'm just going to switch the order. I can see that this is actually going to be an up-down opening hyperbola that's centered at the point -1, 0. So there's my center point. My a squared is 4, which means my a value has to be 2, and because it's under my y's, I'm counting from my center point up and down 2. And my b value is the square root of 3, so I'm kind of estimating as best I can what the square root of 3 is. I create my central rectangle, I draw in my diagonals, and then keeping in mind it's an up-down or vertically opening hyperbola, I sketch in my curves at the top and the bottom. So now knowing this, I can plug in my a and b values and my h and k values into the formula for asymptotes that we saw on the first page. So keeping in mind this is an up-down asymptote, so my slope is going to be my a value over my b value. And since my k was 0, that's why it's not written in there. But my a value is 2, my b value is square root of 3, and then I plug in my k value with my x. And notice that it's both positive and negative. 2 square root of 3 2 over square root of 3 because we have two asymptotes, one with a positive slope and one with a negative slope. And in this one, I just cleaned it up so that I didn't have a radical in the denominator. So I rationalized my denominator. So my final answer would be plus or minus 2 square root of 3 over 3 times the quantity x plus 1. Okay. And so kind of looking at the opposite, in this case they're giving us our equations of our asymptotes and our vertices. They're asking us to write the standard form equation of it. Again, the vertices give us a lot of information. They give us our a value. The distance from 3, -5 to 3, 1 is a distance of 6. So our a value is 3, which means our a squared has to be 9. So that's one piece that we need for our equation. It also gives us our center point, and it tells us that we're opening vertically because it's our y coordinates that are changing, which means that our y's are going to come first in our equation. Okay, so in order to find the other pieces of information, we have to use our asymptotes. So if you look at the slope of your asymptotes, the slope is because we're opening vertically, remember it's your a value over your b value. And the slope is 2 and -2, which means that our b value, to have our a over our b reduced to positive or -2, our b value would have to be 3/2, or 3 over 2, which tells us our b squared is 9/4. So now we have all the information that we need to create our equation. So we plug in our h and our k values. Because the y's come first, just make sure that you put your y coordinate of your center point here, and then minus x minus your x coordinate of your center point, your h value, and then your a squared and your b squared, and then equals 1. Because there's so much, and we're trying to do this distance learning thing with hyperbolas, I'm going to cut out the application problems in this section so you can ignore example 5. Example 6 is just a review of how we classify conic sections that are in general form. So if we take a look here, we have an x squared but no y squared. That has to be a parabola. In this case here, we have a 4x squared and a -y squared. They have opposite signs. This is a hyperbola. In this case, in letter C, we have 2x squared and 4y squared, both positive but different coefficients. That makes it an ellipse. And in letter D, we have 2x squared and 2y squared, exactly the same leading coefficients. Those are circles. So see me on Thursday. Just shoot me an email. Let me know if you have questions and you'd like to meet up on Thursday. Remember, from noon to 1 is the extra help. And as always, shoot me an email. And I hope I get to see you guys soon.